right.
Hey.
Are we muted here?
No.
Cool. So, another thing that came to me as a vision, and I've been on a roll because it's been over 24 hours now, is how time, we know that time is an indelible part of the four-dimensional time-space, but only the three dimensions are spatial and are actually three, as in, having a certain sense of being, any one of them is one of the three. As part of the four-dimensional time-space, time is not a spatial coordinate, so it actually does not mean faithfully to speak of time as the first, the second, the third, or the fourth dimension. It is a time-like dimension of the United Four, which means that in each of the three other directions, think of that like axial orientation, you can rotate in this plane, you can rotate in that plane, so two planes of rotation, two-dimensional references already define a 3D angle. So, say you've got a gyroscope measuring, or a MEMS sensor measuring where it's up and down. Either measuring from gravity, so just like a weight suspended from a thread, or measuring from a gyroscope reference. So if you are in space, you can still spin up something that can have angular momentum, torsion, and it will keep that plane of orientation reasonably, if there's no friction, if there is no torque, if there is no shock involved, or electric influence, it will keep in that plane, and as you rotate, you can still figure out where you are pointing in reference to that initial angle. With time, it becomes an interesting question whether you can align yourself in the direction of time or indeed opposite of time. Well, the answer is no, because as you move down and up time, so most phenomena are actually reversible backward and forward in time. You cannot move away from it. You can only be either stationary relative to it or moving in a direction aligned with it. So check this out. It explains simply. It's mathematics. It's formal, but it's simple.
Yes.
You've got three pointers, three vectors, or three XYZ axes when it comes to space. You've learned that at school, that you can have a vector saying, according to Pythagorean theorem, how much forward you need to go, how much rightward you need to go, and how much upward you need to go in order to get to a certain position. And from the zero, if you're looking from zero, if you just reduce those numbers to the closest ratios or functions as the solutions to the Pythagorean theorem, very often you'll have radicals, very often you'll have roots there. And very often you'll also have complex numbers. That's because it's weird. Now, what is something that explains to you why it is the case in nature, why you cannot run in the opposite direction to time? You can only run parallel, perpendicular to it, or indeed in the same direction as it, so aligned with it, both in orientation, so both in angle, so you parallel, and also in the sense, so backward or forward. It's always forward, not backward. So it's different than x, y, and z, because x is plus or minus infinity, same for y and z, because from zero you're looking in any direction of positive or negative, to define a solid angle. It's called a solid angle. So the axis of orientation, say of a rotating gyroscope or of whatever, say you just in say the symmetry axis of a locomoting vehicle or animal. So it's usually forward, left, right, up, down. They're fixed, and you can clearly kind of draw a line how it moves forward. And machines are built with respect to that, and animals grow and evolve with respect to that. But time, you cannot point with your spatial alignment where time is. But I'm saying movement in time, you cannot point in it because things are rotating and things work in cycles. So if you have a spinning object, there's no use describing it generally, like writing a book about where it's pointing in space, because if it's rotating, it can be crazy rotating, so every second it might change the direction. So it's no information at all to tell you in which spatial direction it is. But if you can define some phenomena, if you say, if I cannot trace it and perfectly model it, but I can define it, and then you say that a certain perfected description of it is most forward in time. But you can also run perpendicular to time, so you can run at 90-degree angles to time. That's an idealized version, and there is theoretical no-go theorems. So there are in physics theorems, like in mathematics, that you prove something and it helps you think because it shows you a further truth. But in physics, they are called no-go theorems, and they're about what you definitely should not be able to do, and here is proof, as opposed to what definitely exists and there is proof. The proof of the non-existence of something is, or at least can be, more valuable than the proof of a specific thing. The world is characterized by the multiplicity of specific things that also change, and from it being one thing, if they break up and recoalesce and recombine, you can no longer separate them, like saying here's object A, start and finish, then the space in between them, then object B, start and finish. No, you have a linked system, a system which respects also time-like interactions, and which is linked mutually. So it's not something like a time machine. You go so much in the future that you just develop a time machine, and then you travel in the past and alter the whole history, and suddenly the world becomes made out of many cycles, and each one is like a variation on the previous theme, but it gets altered by the continuation of the whole loop. You can't escape it because you keep traveling to time, and unless you choose that, unless you keep traveling to time, you cannot observe what the change is, and you cannot faithfully make sense of what you observe in current reality. So, you know how they say, how they have Red Alert first in the sequel, and you have
yes,
Doctor Who, you have all these stories how somebody travels back in time to fix something. Now, I'm saying, if that happened, or Terminator, another one is Terminator, a really good one. I recommend, do you know the Terminator, the movie?
yes,
The first one. Yeah. So it's just a finite being, a robot, convincingly could do that. A synthetic machine, anthropoid, simulating a human, and sharing its efficiencies. But they teleported from the future into the past in order to destroy the past and bring about the future faster, right?
yeah.
And look. Now watch this. Just check this out. It's unbelievable.